Here's a quick physics problem called the curling stone momentum problem. Here's the setup of the question. If you have two curling stones, we have this blue one or teal one here, and our salmon or orange one here. And the teal one lies in this sort of straight line. And notice how the red one is not going to hit it straight on. It's going to hit it somewhere about here. And the question is asking, determine the speed and direction of the orange stone after the collision. So if this is our before, if we look at our after, or in this case during the collision, the orange stone is going to travel off somewhere in this direction with some sort of speed. And we want to find what that is. So let's just write some things down first. M1 will make the orange stone. And that is the mass of the orange stone, which in this case is given of 17.9 kilograms. And we also know that the teal curling stone, we'll call M2, has a mass of 12. Alright, so the first thing we want to note is that in this system, and before and after the collision, momentum is conserved. So our P initial of the system is going to be equal to P final. And notice how the P initial of our system is only going to be anything that is involving the orange stone, because the teal stone is at rest. So it won't have any momentum because momentum relies on velocity and mass. So if you have no momentum, that means you either have no velocity or no mass or both. And in this case, the teal stone does not have any velocity. So we know what our P initial is. It's actually pretty easy. So if we just do P initial is equal to mv m1 times v1. And this, if we just plug it into the calculator, is going to be 2.86 times 17.9. And notice that this is all in the x direction. So if we just plug this into the calculator, we will get 51.194 Newton seconds. So this is going to be the starting. So notice how that after we're going to have a little bit of y, and I might as well draw this vector too. But notice how these y's will have to be equal in length, because remember, we started our py initial is 0, so that means py final must also be 0. So these two must match. Well, how can we find this component of momentum? Well, we can take that component of velocity, right? So if we want to find this y, we know that sine theta equals y over 3.33 as given right here. And we also know that theta is going to be the 13.45 degrees. So we know that sine of 13.45 degrees times 3.33 gives us the y. And this is going to be our velocity in the y direction, I should mention. And plugging this in gives, make sure that your calculator is in degree mode. So we get sine of 13.45 and then times 33.33, and this will give us 0.775 meters per second downwards. So I should mention that is negative, and this will be negative in the front here. So continuing on, we want to know what the angle is, right? So, well, let's just go here. If we know that this is going to be 0.775 meters per second, we know that this must be we know it's not 0.577 meters per second. If we know that this is the y velocity, we know that if we multiply m2 times vy, we get py of the second stone. And we know that this py of the second stone should be equal to the exact opposite of py of the first stone, because they need to cancel out to make 0. So in this case, we will just multiply the mass, which is, once again, 12 kilograms, times this velocity, which gives us 12 times 0.775, 9.3. 9.3 Newton seconds. So that means this must be 9.3 Newton seconds. But we also happen to know what the mass is. So if we know that px, or actually no, py of the first one is equal to this 9.3 Newton second value, and we know that this is equal to mass 1 times Vy, then we also can just find Vy by dividing. So Vy, but for the first stone, I should mention that this is for the second stone, is equal to 9.3 divided by the mass, which was 17.9. And this will give 9.3, 17.9. This gives 0.520 meters per second. So we will just put this down here. 0.520 meters per second. So now all we got to do is find this x velocity. So we know that v, the momentum x before, is equal to this 51.194 Newton second value. So we know that px initial is equal to 51.194 Newton seconds. And we know that it's going to be equal to these two combined. And we can actually find this first one combined. And this will be pretty easy. So if we want to label it, we can label it as Vx of the second one. And this is equal to similar setup as the Vy, but instead we use cosine 13.45 degrees times 3.33. And this should give us cosine 13.45 times 3.33. And this gives us 3.24 meters per second, which we then take, the mass to find the momentum. So px of the second one is equal to 3.24 times the mass, which is 38.86 Newton seconds. So now we subtract this from the 51.194, which is 12.334 Newton seconds, and this will be equal to P of x of the first one, which is our red curling stone. So if we know the P of x of the red curling stone, and we also know the mass, well, if we divide it by the mass, if we divide by mass, we should get velocity in that direction. So we'll divide by m1, and this will give us 12.334 divided by 17.9, which is equal to 0.69 meters per second, is equal to Vx of the first one. So now we know Vx and we know Vy. So now we can calculate the speed and direction. Speed is pretty simple. Speed will be equal to the Pythagorean theorem of these two. And this is equal to, if we just calculate it, 0.69 squared, 0.52 squared. This gives 0.86 meters per second. And then for the angle, we can just use tan theta equals sine, which is the y value, which is 0.52 over 0.69. And then we find theta is equal to arc tan of this value, which is equal to 37 degrees. And that is our answer. It is going at 0.86 meters per second, 37 degrees north of the horizontal. All right. Thank you for watching.